I'm going to start by explaining in this short video what does it mean to be an inverse of this linear function. So if you were present with me in class, I would like you to make two large circles. And then we are going to use the calculator to demonstrate this. The first thing I'm going to do is I'm going to reset my calculator. So if you are present with me in class, I'd like you to do the same. Find the blue key that says second, press it one time. Find the plus sign in the bottom right-hand corner, and then hit the button 7, 1, 2. And it's going to say RAM cleared. We just cleared it. You can help your partner at any point if they fall behind. Now I'm going to go up to the y equals in the top left-hand corner after I've cleared the RAM, and I'm going to type this in. Y equals 2x subtract 3. Not negative sign, subtract 3. In order for me to demonstrate and for you to better understand what is an inverse, let's call this function f of x. Let's call it f of x. And so at this point, I want you to hit two keys. I want you to hit the second key, that's blue, and in the top right-hand corner, I want you to hit the key that says table, second table. Now, I can take any ordered pairs from this function. I'm going to type in 0, or write down 0, negative 3. So I can see that for the function f of x, 0 is mapped on to negative 3. And I can take any one of these. I can see 3 is mapped on to 3. I can see, just randomized here, I can see 7 is mapped on to 11. Those are all random or arbitrary numbers I chose, and then I took the corresponding output value. Okay? So here's what this function means. Function f says, if I'm in a car and I put it into drive, I'm going to go forward. And so when I put it into drive, I plug in 0 and I go forward, and what do I end up with? Negative 3. If I drive forward, I'm using this analogy. If I drive forward with function f and I plug in 3, I drive forward, what do I end up with? 3. If I drive forward with function f and I plug in 7, what do I end up with? 11. Now here's what inverse means. Inverse means that I have some random function called g of x. And inverse means that I reverse it. So on your car, you're going to go to the R and you're going to reverse it. And when you reverse backwards, when you plug negative 3 in, guess what you're going to reverse backwards to? 0. And when you reverse backwards from 3, you get 3. And when you reverse backwards from 11, you automatically get 7. So if this is function f, the inputs are on the left and the outputs are on the right. Now when I find the inverse of f, let's call that g of x, it swaps. So the inputs become the outputs and the outputs become the inputs because we reverse the order. That's what we're going to do. So how do we actually do that? Well, let's start off right now with like an 8th grade level math problem. The first thing I'm going to do is I'm going to replace f of x with y. Step 2 is I'm going to switch the x and y. And step 3 is I'm going to isolate the y. So to get y by itself, I'm going to add 3 to both sides. X plus 3 equals 2y. To isolate the y, opposite of multiplying by 2 is dividing by 2, and I get x plus 3 over 2 equals y. Now, I could rewrite this if I wanted, like x over 2 plus 3 halves, and that's okay as well. But either one of these is okay. Well, now, what I need to do is I need to write this as the correct. I need you to stand up right now. You can learn from over there, but you can't have your eyes closed. Stand up over there. So I need to rewrite this as the inverse. So the inverse here is going to be denoted with this little negative 1. F to the negative 1. This is the inverse of this original function. If I take this function and I plug in negative 3, I can promise you I'm going to get 0 if I did the math right. If I plug in 3, I should get 3. If I plug in 11, I should also get 7 if I did that correctly. Okay, are you ready? Go back to your partner right now. Here's your first problem. First problem without my help. Let's do one more very simple problem. Very simple. Let's start with y equals negative 1/2 x plus 5. Nicole and Jocelyn walking around. While the music plays, I'm going to give you 2 minutes talking together to find the inverse of this function. Wrong answer is totally fine. Need help? Not a problem, but I need effort and working with your partner. Begin. It's okay if you're not done. The first thing I'm going to do is I'm going to switch the x and the y. This is a great example of where I saw students, I knew they knew the procedures and they made some really small algebraic mistakes yesterday, but they knew the procedures that could give them half credit. So they started by, this would be really common, by subtracting 5, keep watching. Then they recognized that in order to isolate the y, they're going to multiply by the reciprocal. One of the common mistakes I saw students make is they forgot to include the negative sign. What happens here is that those are going to simplify to 1, and now, here we go, you ready? Negative 2 times x is negative 2x. You can put a 1 on the bottom if you wish. Negative 2 times negative 5 is positive 10. If you want to put a 1 on the bottom, you can. But here's the mistake students made. Look up here. When I saw students do this yesterday, negative 2x was common, but when they had to multiply by 5, they thought they had to take the 5 times the top and the bottom. And so I commonly saw this. Positive 10 over 5. Because they'd go, okay, 2 times 5 is 10, 1 times 5 is 5. We're only multiplying the negative 2 times the negative 5 and the 1 times the 1. And it's not even necessary for you to put 1s on the bottom. Okay? This is the inverse of this original function. Okay, turn to your partner and tell your partner right now, I have some students that are still working. I'm going to go over the top. Make this a y. I'm going to switch the x and y. Okay, we're going through the procedures now of isolating for the y. So I'm going to start by subtracting 15 over 2. Subtracting 15 over 2. These are additive inverses. Okay, now I'm going to multiply by the reciprocal. Reciprocal does not mean we change the sign. The 2 simplify to 1, the 5 simplify to 1, and y is by itself. All right, let's distribute. We get 2/5 x, subtract 2 times 15 is 30, 5 times 2 is 10, and now this simplifies. 30 over 10 is 3. This original question was an h of x. Doesn't matter if it goes in the front or in the back, but this is h of x, and we're going to denote it as being the inverse of this original function. Okay, are you ready? Practice quiz right now together. If you and your partner got to combine for this quiz, did I make a mistake?
No, I just wanted to ask if the negative 1 or the on top of the h of x, is that necessary? Would we mark that wrong?
Oh, great question. That's a great question. He says this necessary. It is at this level. I didn't count it wrong yesterday, but I would this time. Yeah. Did everybody hear that? We do want to put that. Okay, you ready? With your partner, if you got to combine, and you got to verbalize for me right now, don't do this, but let's say you had your phone and there's an app, and I said go, and you had 30 seconds to give me an answer. I want you to describe, don't tell me these procedures, describe how the inputs and the outputs relate from the original function to the inverse function. Ready? Pretend, you don't have to pull out a phone, pretend you had 30 seconds to come up with an answer together. So, the inputs of h of x, the inputs of h of x become the outputs of the inverse of h of x. And the outputs of h of x, or the original function, become the inputs, okay? At this level, at the honors level, even though I know you're getting, if you say flip, don't just say they flipped, they switched. Tell me a little more. The function g of x. And I've graphed it as accurately as I can on this Cartesian plane. You can see specific ordered pairs that belong on the function g of x. And if I asked you to do the least amount of work and to accurately graph the inverse of g of x on this same graph, on the same Cartesian plane, how would you do that? Turn to your partner. Here's the easiest way to do it. There's multiple ways that we can do it. I can think of 3 ways, but here's the easiest way. If you can see good intersection points, and I'm going to write those down. This is left 1, down 1. Okay, left 1, down 1. This is stay and go up 1. Stay, go up 1. This is right 1 and up 3. Right 1, up 3. This is right 2 and up 5. Right 2, up 5. So I'm writing down the ordered pairs, and that belongs to function g of x. Now, I know that the inverse of g of x, I can list 4 pairs. What are 4 pairs I can list? If I understand the relationship between inputs and outputs as it compares the original function to the inverse, what can I say? What also belongs to it? If I take the input and make it the output, I take the output and make it the input, that's one ordered pair. 0, 1 becomes 1, 0, 1, 3 becomes 3, 1, and 5, 2 becomes 5, 2. Now I'm going to graph those 4 ordered pairs. Negative 1, 1 just happens to be in the same place. I'm going to make circles. 1, 0 is here. 3, 1 is right here. And 5, 2 is right here. I'm going to take those, connect it, and this is going to be the inverse of the original function. Turn to your partner. I would like you to find, as practice, do the procedures to find the inverse of g of x and the inverse of h of x. Working with your partner, please begin.